From theCUBE studios in Palo Alto and Boston, bringing you data-driven insights from theCUBE and ETR. This is Breaking Analysis with Dave Vellante.
The market is trying to price a transition that it really hasn't fully internalized. It sees Nvidia's market cap with a 5 handle and assumes the story is one of mostly GPUs. Well, we believe that is the wrong mental model. And there's a shift underway. It's kind of closer to the risk to x86 transition, but we think it's far more substantive than that. While x86 became the de facto standard, it largely grew proportional to normal server and PC refresh cycles. The dynamic powering NVIDIA is far more powerful in our view and not well understood. NVIDIA is creating a new platform by becoming the default substrate for enterprise computing. And that platform pulls everything else into its gravity. Now, in this cycle, the unit driving growth, it isn't a PC device or a server, it's the AI factory, which is a rack scale system that takes power and data and compute and software and then turns it into intelligence through tokens and reasoning and, of course, automated workflows. So our core premise suggests that NVIDIA is assembling a new enterprise platform. It's not simply making workloads run faster. And the AI factory in our scenario is going to absorb the enterprise functions that x86 typically and historically provided. You're talking about things like execution and storage and databases and recovery and security and management and just backwards compatibility. Now, the nuance here is enterprises, they really don't run clean, deterministic systems today. They actually run fragmented application estates that are held together by human semantic reasoning. So in other words, humans have to reconcile exceptions. They got to make corner case approvals, and they're often required to do manual recoveries. The promise of the AI factory is not just faster compute in isolation. It's automating these edge cases that currently require people to interpret, people to coordinate, humans have to rationalize inconsistencies. The rack now becomes the computer. Okay, so this is not just NVIDIA marketing. It is that, but it's also profound. NVIDIA's annual cadence, comprising CUDA, DGX, Mellanox networking, Grace Hopper, Spectrum X, Blackwell, things like Mission Control, Vera, Rubin, Omniverse, eventually Feynman. These deepen work around storage and context. And to us, this looks like a purposeful build out of a full stack enterprise-wide platform across an ecosystem. And very importantly, we think that x86, it doesn't just vaporize, it doesn't go away, but it gets absorbed into this AI factory framework. And we're going to talk about that today. So we see an architectural adoption path where deterministic workloads are preserved while the AI factory grows around them. This is going to lower migration friction. And this platform is going to learn from the reasoning traces of humans that are monetizing intelligence, all while this new platform earns loyalty, otherwise known as lock-in, through capabilities and superior economics. And in this breaking analysis, we welcome back David Floyer, who's been working with George Gilbert and myself to lay out these profound changes that are coming across compute, networking, storage, databases, recovery, security, and operations, and why the transition will be more significant than prior platform shifts, and how frontier models are becoming the migration tools while the platform is being built out. Our goal here is to replace market confusion with a coherent map. What's already here, what's missing, and where enterprises and vendors get forced to adopt whether they want to or not, and how it's going to change the technology model, the operating model, and the business model of every organization on the planet. David Floyer, welcome back. Great to see you again. Awesome work as usual. I'm really excited about this session.
Great, a great subject. I've been working on this for some time.
Yeah, I know you have. All right, let's start by looking at the stock market indicators. Coney, if you bring up the first chart, and we're going to isolate on a few of the leading semiconductor players here. We're comparing the key financial indicators from 5 companies, Nvidia, AMD, Intel, Qualcomm, and Broadcom, and we're noting up top the year-to-date performance. This is at the pre-market as of Friday morning. The market was up that day, up significantly. But anyway, at that point, Intel was up almost 200% year-to-date. AMD 91%, had a blowout quarter recently, and those two far outpacing Broadcom and Qualcomm. And then Nvidia, you see Nvidia plodding along at like 13% valuation growth, stock growth, in this kind of lower double digits. And below that, look at the revenue projections, the growth rates, and the forward PE ratios of these companies. And notice Nvidia is much, much larger from a revenue standpoint. It's projected to actually grow faster and throw off way more cash. I mean, more than 3x, the forecast on Broadcom, and orders of magnitude more cash than the others. Yet its price to earnings ratio is lower than all of those except for Qualcomm. Now, the reasons typically given are that the stock, it's run up a lot, it's got a $5 trillion market cap, and it can't continue, especially, thank you, Coney, as it faces competition from not only AMD and Intel, but also Broadcom and Google with TPUs, David, and AWS with Trainium. But David, 2 things. One is we've never seen anything like this before. And the second point is, we think NVIDIA is actually going to hold its share of the accelerated computing market. It may even gain share, as incredible as that sounds. What are your thoughts on this, David?
I agree. It has volume. The things that you need in order to keep going are that you're delivering value. They're doing that on a yearly cadence, improving things. Their volume is 80%, probably closer to 90%. That will enable them to invest and get the equipment from the marketplace that they need, and they're working very hard on velocity on their yearly cycle. I believe they're in a very, very powerful position, more powerful than any of the other competitors you highlighted.
All right, so strap in, because we're going to go deep into NVIDIA today and how we see this playing out. We probably don't do justice to the supply chain expertise that NVIDIA is bringing up and its ecosystem, although we certainly will touch on both of those. But let's get into the core of our thesis. Coney, if you bring up the next slide. So as we said at the intro, NVIDIA, they're building an entirely new platform we think is going to change the technology, operating, and business models of virtually every company. When we shifted from on-prem to SaaS, it really affected the IT department. It certainly affected software companies, and it certainly changed the pricing models and the operating models of sort of from IT standpoint. We think this extends much deeper than that to the models of all companies, as essentially they start manufacturing, or at least tapping manufactured intelligence and monetizing that. So you hear this word tokenomics thrown around a lot, and we see the cost per watt to generate tokens as one of the most important measures of cost in a power-constrained environment, because power for operators is essentially fixed. So if you can do orders of magnitude more work each year, which is what NVIDIA is delivering within the same power envelope, that means money. This is Jensen's new law. We wrote about that last year. Now, frontier models here shown in the middle, David, are crucial because they abstract and they absorb much of the traditional x86 functionality, but they do much more than that. Please elaborate on these points. Thank you, Coney.
Yes, so the frontier models are absolutely crucial. Those are the ones which are improving, and every time they improve, they drive more demand for these tokens. The more that they improve, and they're driving it very, very fast indeed. We're looking at amazing improvements in both quality and volume of the tokens driven by these frontier models. What's very important in this whole framework is x86 absorption. X86 is where the majority of data and applications sit at the moment. And a very important joint venture by Intel and Nvidia last year was to bring Intel's x86 into this platform to be able to bring it in the same way as the ARM CPUs as the ability to have racks of x86 linked in the same way with the DPUs and the networking and all of the other functionality of the platform. That was a crucial decision made, and is going to come in this year, later this year, in spades as people understand the impact it's going to have.
All right, thank you for that. So one of the things we've been discussing on breaking analysis in theCUBE is the idea that plugging an LLM into a vectorized database is cool, but really didn't drive the type of enterprise value that got people really excited. And we've come to the conclusion that we have to blend deterministic software with probabilistic systems. And Coney, if you bring up the next slide, this is necessary, to govern and guide and ensure reliable and predictable outcomes. So, but you can't just bolt LLMs onto SaaS and expect amazing results, because as you point out, David, on this slide, deterministic systems today, the ones shown on the left, ERP, CRM, human capital management, et cetera, they're actually fragmented systems. They all have different data models. They got different data warehouses or data marts. They're in departments. They may be the single source of truth within that department, but across departments, it has to be reconciled by humans. These humans have tribal knowledge. They do this by spreadsheets. They have conversations in the hallway. They have meetings. They do whiteboard sessions. They do process discovery and the like. So, David, explain how you see this playing out as you're suggesting on this slide, that and bring that back up for a moment, if you would, Coney, how these new platforms are going to take over much of what humans do today and spend their time reconciling.
Well, as you said, we live in what we think and say is a deterministic set of systems. The reality is that it requires a lot of people. It actually is very, very probabilistic, their way of dealing with this. You don't necessarily get the same result each time. It's people who are doing their best to make sense out of this mess of different data. One of the ways that they try and do this is, for example, by having data warehouses, bringing all the data in, trying to make sense of all this across it. Even then, though, the conflicting semantics are there all the time. And in addition, this is something that takes time. It's not real time. So if you want to be able to get to a much more efficient way of doing things, you've got to get rid of all of this work that's being done of no real value. Got to get rid of it and have a real-time system with real-time shared semantics across the organization as a whole. Now, people have been trying to do that and almost universally failing, but we believe that the systems of the future, this combination of x86 and the NVIDIA platform, that will be able to, for the first time, use the frontier models to provide engagement to, over time, get rid of these conflicting semantics.
Yeah, and we're going to talk some more about that, but we've got the whole industry, the whole BI industry, the $50 billion business that's been built up around metrics and dimensions and the like, and partnering with the analytics players but that essentially has become a historical, look back version of the truth. And the real-time enterprise is organic and is a different animal, and we're going to talk about that a bit. But our fundamental thesis here is that organizations are going to begin to monetize intelligence by putting the tokens that AI factories manufacture to work. So if you bring up the next slide, Coney, this shifts computing from kind of a back office IT cost center into a revenue generating engine. We've heard this before, but this takes it to new levels. It really dramatically expands the total available market for AI factories relative to the Moore's Law cycle, which has essentially powered the last 3 decades. And we shared up front that consensus revenue estimates for Nvidia are north of 350 billion, with an accelerating growth rate. This shows here 65% last year. We're saying north of 70% this year. So, David, kindly walk us through your thinking on the opportunity here. Thank you, Coney.
Well, yes, there's enormous revenue and investment that's coming through to that, and the fight. If you look at new companies coming through at the moment using these types of technologies, the startup companies, which are starting by using frontier models, you are seeing that their dollar per employee, revenue per employee, is around 10x what the traditional companies are. There are all of the ratios are moving up, but the new ones are looking very, very different. And you're looking at potentially billion-dollar revenue companies with only a few people driving it. So that's the fundamental change, and that's the fundamental overhead that all of the problems we talked about, the problems, semantic problems, all the other issues about all the different systems not talking to each other properly. That is the impact it can have on the revenue per employee. And of course, the faster that Nvidia is bringing these new things out, at the moment it's constrained more by supply than it is by demand. So the 70% is a constrained figure. It will become higher as those constraints go over time. But that is a rate of change like nothing else we've ever seen before.
Thank you, David. Coney, bring up the next slide, because I want to quickly take a look at the closest and most recent platform parallel. I mean, it is still dramatically different, but the battle between RISC, which is stands for Reduced Instruction Set Computing, and x86. In the late 80s, for those of you who weren't around, in early 90s, all the major computing players at the time, IBM, Sun Microsystems, Digital Equipment Corporation, Data General, and others were touting their own HP, right? HP, absolutely. Thank you. Were touting their own versions of RISC, which was a much more efficient architecture than x86. There was a company called MIPS that was doing their own instruction set, competing with Intel. But x86 and Intel won because it had superior economics, not necessarily due to the architecture, but due to the relatively much higher volume of PCs. And x86 with Intel and Microsoft Wintel became the dominant standard in PCs, and then that migrated its way into the data center as well. David, your thesis here is that the transition to AI factories goes faster than the x86 transition, which kind of played out over most of the decade. It kind of makes sense. We have cloud now, we have internet, we're moving at a breakneck speed. We have AI. Thank you, Coney. State your thinking here and add any color.
Yes, I think you've covered it very well here. Yes, it took a long time. We were working during this period at IDC, and we're watching the slow increase in x86 and how it moved up the stack and into more and more higher levels of workload. And it took many years for that to drive up that. We believe that the power of these tokens and this reasoning and this intelligence is going to make that migration much faster this time, and it's still going to take we believe about a decade altogether, but that's an awful lot of that change is going to happen in the first 5 years.
Yeah, now Nvidia's portfolio goes well beyond GPUs. I mean, this company started out making graphics accelerators for gaming. Coney, if you bring up the next slide, I mean, it's expanded into a major industry product line comprising, it's got hardware, software, libraries, networking with the Mellanox acquisition. I mean, it's embraced Ethernet. I remember the day where people said, InfiniBand's dead, Ethernet's going to rule the world. Well, InfiniBand is growing, Ethernet is growing, and Nvidia has built purpose-built Ethernet for AI, called Spectrum X. And look at this chart. There's much more. They're on this annual cadence with Blackwell, and they've introduced NIMS, and of course Vera Rubin. They added LPX, which is the Grok acquisition, and they redid the storage, architecture at GTC 26. They announced it. They announced, Feynman. They have Omniverse, which is their digital twin. So, David, this portfolio expansion has been phenomenal. You just look at this chart. You've got something on here, so it's not just chips. You're right on. Take us through this.
It's breathtaking, isn't it? I mean, every time that we go and hear and Jensen talk, we have more things coming out, and when you look in detail at all of the large and small changes and improvements, particularly now in software and particularly in functionality, deeper functionality, it's improving at a tremendous rate. The focus to begin with has been on efficiency of running these GPUs, of bringing down latency of the tokens and latency of the questions asked. That's been a major. They're putting together hundreds of thousands of these GPUs and running them as a single system. And that is so powerful. And then if we can take that system there and then add in the absorption of the current systems and blend the two together, we're going to have an amazing capability that I think the phrase that you use changes it completely from back end to driving the companies as a whole. This will be the way the companies will run and increase their revenue, etc., is through this end-to-end architecture.
Yeah, so the unit of compute, it's not the server or the blade. It really now is the rack, which scales up, it scales out, it scales across data centers. So, David, I want you to explain why this is important, and I want you to, Coney, bring up the next slide, David. I want you to take us through this. You're showing here the rack on the left. You've got models in here. You got DPUs. You got KV cache, which is this really critical layer. Walk us through this slide, if you would.
Yes. The old unit of compute, if you go to AWS, you buy storage and you buy cores. That's the unit that you buy things in, and then the rest is you putting together everything else around it. What Nvidia has done is create the rack, which includes the network. It includes now the storage functionality. It includes all of the memory across all the different types. It includes the GPUs, the CPUs, the graph PUs. All of these pieces are linked together as a single system, and its objective is to deliver intelligence, deliver capabilities. The rate at which these improvements has happened, the improvements have been really from top to bottom. They've been improvements in software, improvements in hardware. It's not just the traditional hardware's getting faster. It is the end-to-end performance is improving at a dramatic, both in terms of cost and in terms of functionality. I have never seen a set of products improve so quickly over any length of time. The change is 10 to 1 per year in terms of cost per token that it can deliver. That is something we've never ever seen before. And that change in price, but that's over a year I was talking, and that change in price is just driving more and more demand for this.
So we said earlier that x86 doesn't vaporize, it doesn't just disappear. It gets absorbed into this new architecture. So let's talk about the sort of the transition and how that happens. I mean, the estimates, David, you shared with me the other day is that accelerated computing is 2x the size of the general purpose computing marketplace, and within, let's say, 2 to 3 years, it's going to be a 10x factor. That has implication for developers. They're going to, have to write to CUDA, although of course there will be abstraction layers, but the best software is going to be closer to the CUDA architecture, and the best developers are going to migrate there. That's our prediction. But you mentioned the deal between Nvidia and Intel. It's a signal that x86 is not only in transition, but it just doesn't simply disappear. So, Coney, I want you to bring up the next slide and have David. I want you to explain how the legacy estate gets absorbed into the AI factory framework and what that means for customers.
Yes, clearly there is no way that we can go from where we are today with the distributed systems not talking to each other and go to a system where magically everything is all connected in one go. So it has to be stage by stage. The way that I think about this is you take a particular business unit, a business process, you might take inventory or whatever it is, and you apply the frontier models to look at all of the different systems that are impacting inventory, the purchasing, the warehouse systems, whatever it is, and you look at that and you resolve the semantic information between them. That's work, and that's work done by people, experienced people there, working together to move slowly through the organization and bring in the x86 stuff, and then bringing those over to work in tandem with the new platform. It's really it's just an extension of the platform. It's part of. You need CPUs, you need GPUs. it'll be just racks of these specialized Intel processors which have the capability of linking in the same way as the ARM processors do. The ratio at the moment is, you know, multiple.
Well, it was 8-1. Yeah, now
Yeah.
they say it's 4-1. Lisa Sue said today it could go to 2-1. This is the ratio of
Yeah,
GPUs to
I
CPUs.
personally think that this is going to be so much more efficient in the use of those processors than the way it's being done today. At the moment, if you've got 14% utilization, you're doing really, really well. 4% utilization is more closer to it. You should be able to get up into up to the 40% in terms of managing the utilizations across the whole system. So I don't believe they'll need that number of CPUs. It'll be some ratio in the middle there.
Well, I think too, and this is where I think the market's confused. Maybe not confused. They're watching the headlines, and you can see it in the tape. You can see the momentum that Intel has. Well, Intel equals CPU. That's goodness. AMD, mostly, Intel's main competitor in CPU. That's goodness. ARM, okay, CPU. Well, Vera is a CPU, and who's going to have the best CPU for the AI factory? We think it's going to be Nvidia. So this is where it gets closer to our core thesis is around functions. So it's the functions. If you look at the course of the Moore's Law era, Intel, they went from basically just a PC microprocessor provider to they became an ecosystem leader that spanned PCs and had functions around up to the data center, networking,
Security.
wireless, I/O, storage, graphics, security, the whole thing. And so the CPU became the central point of control for computing. And Coney, bring up the next slide, because David, you laid it out beautifully here. The CPU became the point of management. It wasn't necessarily the most efficient. It wasn't the most efficient, as you say. We've seen offloads, think the DPU, things like that have emerged. But now we're into the AI era. David, take us through how you see this evolving in the AI factory.
Yes. The x86 is, as you say, much more than just the processing. It's doing a huge number of things. It's managing storage. It's managing databases. It's managing recovery. It's very important elements of security, especially in high secure areas like government, etc. And it's management of the whole management of the system goes through the x86 architecture. And if you take, for example, like an Oracle database, it is a masterpiece in using that x86 to be able to recover, to be able to share data, recover everything. It's an amazing capability that's being built up by both the software vendors and the hardware vendors over time. But we're now in a different situation. The capabilities, for example, the network, are so much faster than PCIe or what is done on the x86. So there has to be a hybrid implementation of x86 functionality or what it does and how it's going to be done in this new combined absorbed Intel x86. It's specifically the work that Intel and Nvidia are doing, how that combines to provide these environments. So execution has to go across many more things than just the CPU. It has to go across, DPUs, XPUs, etc. Storage now is is very, very different in terms of its the way it's being handled. You've already got new companies like Vast who are doing a great job in terms of bringing their type of functionality in a very different way than the traditional storage. Database have to develop semantic capabilities, much stronger semantic capabilities. They have to develop parallelism, much higher levels of parallelism. Recovery has to go at a much deeper level, including semantic, as well as just the data itself. Security, that's got to go right the way across the code, the data, the APIs, the different parts of it have to have that security. We're entering a new world where there are bad guys using the frontier models, and the frontier models have to be there to protect yourself. And then the overall management, the automated operations. This is incredibly important. The system as a whole has to be managed. Obviously, it's going to be distributors as well, but as the system as a whole has to be managed across that. And by managing it, it'll be more efficient, but and also far more resilient and high levels, which is absolutely going to be needed if you run your business on this. This becomes the front line of your business.
When you think of some of the great acquisitions in the industry over the years, I mean, obviously YouTube was more consumer. Apple, of course, with Next. When you start getting into enterprise, you can't help but think of VMware, which EMC, I think, paid $630 million for VMware. IBM's acquisition under Palmisano, I think it was under Palmisano, of PwC, transitioned IBM into really a services company and kind of in many ways carried on from Gerstner and saved the company. Sun Microsystems, purchased by Oracle, was a great acquisition. I think they paid $7 billion, and that became the integration between hardware and software. I'm not sure any of those compare to Mellanox. I think it's going to prove to be one of the most strategic and perhaps the greatest acquisition in the history of the enterprise computing industry. Nvidia paid about $7 billion for Mellanox. Their networking business is at a, I don't know, $40-45 billion run rate business today. It's got a $5 trillion market cap, which is, you think about without networking, there wouldn't be, the Nvidia as we know it today. So it realized that AI at scale was not going to succeed without a new networking model. And NVLink, the whole scale up, the purpose built for AI Ethernet, which they call Spectrum X for scale out and scale across, and the Bluefield DPUs. These are huge piece of NVIDIA's value chain. Tony, if you bring up the next slide, David, take us through this. David, Mellanox was the most important enabler for NVIDIA's ambitions, their AI ambitions, and they've extended their networking capabilities as you're showing here. What is the role of networking? It's the enormous role of networking. Take us through that.
It is the foundation. You've gone from a world where we were dealing with the number of CPUs that we're dealing with. It was really very low indeed. I mean, we're now talking about hundreds of thousands of GPUs, processors being connected together and working as a single unit. Networking was the single most important area where they invested heavily, and it is by far and away the best in class. It's better than anything else on the marketplace, and that's been the foundation of their ability to scale, to reduce latency, improve recoverability, etc. And there doesn't seem to be a week that goes by where you see some small improvement here in the software, the capabilities of recovering, etc. They have put in an enormous amount of both software and hardware into this networking space.
So at GTC 2016, NVIDIA redefined the storage stack. I wrote about this, basically saying that NVIDIA was prescribing kind of a new storage I/O architecture, which was necessary to keep the system in balance. And I almost even sort of implied they were kind of dictating to the ecosystem, which NVIDIA kind of bristled at. But frankly, it's a mandate. If you don't follow this dictate or this new model, you're not going to be relevant. So what was once seen as tier one storage, remember the EMC symmetrics that sort of defined tier one external storage in the sort of mainframe, post-mainframe world. It's now quite far down the storage hierarchy. You got high bandwidth memory, you got SRAM, you got DRAM, you got lower cost memories, you got KV caches. They're all part of that new storage hierarchy. So it completely changes storage requirements. Taking advantage of KV cache so you don't have to restart, making that more efficient. So as we wrote earlier this year, there's a new mandate for providers. Bring up the next slide, Coney, that you show here, David. Vast. It's kind of redefined storage itself. They've kind of re-envisioned it, but DDN, Weka, the sort of HPC players are now moving into this market in a big way. The market's moving to them, I would say. Dell with its Project Lightning announcement and many others. David, share your point of view on this slide and how I/O and storage has changed and why it's so important to respond.
It is just an amazing change in the architecture. As you say, they said, this is the way that we're going to do it. We are going to integrate the requirements for storage to be far lower latency and take advantage of all this networking that we have here. And make end-to-end communication, direct communication, the norm. You're avoiding going through a CPU or a GPU to do anything. It's set up and then you go. So it really is a profoundly different environment. RDMA, for example, become completely normalized. So you had examples of that with x86, if you like, in the databases, for example, and in those where you could set things up, but it was highly specialized. This is a general architecture for storage. And it's bringing in completely new players. I mean, this was perfect for Vast's architecture, and they took it up aggressively. And as a result of it, have really increased their market share enormously as a result. All of the other vendors have agreed that this is the way of the future for storage. And again, you're seeing small changes, improvements in this whole ecosystem improving. And as the x86 combined systems are brought over, we're going to see that there will be changes in the way that Intel's combined x86 with Nvidia, they work in this area. You'll see far less of PCIe and far more of these types of functionalities.
All right, let's talk about data. When Jensen shows his 5-layer cake, he actually doesn't have a data layer. So, and I always say, hey, let's not forget about the data. So let's talk about data platforms. I mean, the modern data stack, the MDS, is kind of like the new legacy now. It was defined by the likes of Snowflake and Google with BigQuery. Those are sort of the gold standards. But the game has changed. I mean, those were historical systems of analytics, the data warehouse, the lake house. So they all, remember, I mean, for years we've been promising in this industry a single source of truth, but it's never really delivered on that. And so And part of the reason is what we described before, is you've got these deterministic systems, but they're all in silos. And so this has to evolve into a real-time digital representation of an enterprise, what we call an enterprise digital twin. And we refer to this new layer that's a very high value layer in the AI software stack as the system of intelligence. It's maybe the highest value piece of real estate in the new stack that harmonizes data and represents the people, the places, the assets, the things, if you will, the activities or processes in real time, and the state of the business in real time. And this layer is evolving, and it encapsulates the data, the operational data, the technical metadata, the underlying application logic, the business logic, so agents can act with confidence as we enter the agentic era. Coney, if you bring up the next slide, David, we've written about this extensively. What would you add about the system of intelligence?
Yes, I mean, the speed at which the frontier models and the software beneath the frontier models is happening is very, very fast indeed. The frontier models, they're improving dramatically. Underneath it, you've got all of the APIs and the tool sets and everything else which is closely connected with that. And then below that, we see the systems of intelligence, which is working across the company as a whole, and providing the framework, providing all the capabilities in terms of semantic resolution, for example, with the databases like that, providing compliance capabilities, providing security capabilities, providing the ability to develop agents, agentic computing. The system of intelligence is the heart of it, where the company as a whole will map onto this new platform that Nvidia is driving towards. And this is going to make for the first time, real-time analytics, real-time looking at the system as a whole capable. You're now having the capability, the reasoning capability, the ability to combine all these things in real time, which has never been able to be done before. And really the migration of the traditional department by department type systems, the migration of those over to this system of intelligence across the company as a whole.
Yeah, so we're moving from kind of what happened and why did it happen to what's likely to happen next, and why, and what should we do next as a result? What's that kind of next best action? We got to pick it up here. I got to go do the CUBE pod. David, I learned from you years ago to ask the question when vendors come in and give us briefings, what happens if something goes wrong? And the answer to that exposes, the architecture. So the recovery is different in the AI era, and I want you to walk us through why that is, how that is, how you envision restoring state when semantics and processes and organizational context and tribal knowledge is involved in that recovery. And Coney, if you bring up the next slide, David, appreciate you walking us through that.
Yeah, sure. Yeah, I mean, the platform has to use its capabilities to provide this ability to recover whatever happens, whether it's a recovery of an agent or whether it's a recovery of a rack that goes down, or whatever the recovery is. This is the fundamental capabilities. And that is going to be obviously a combination of existing capabilities in the x86 and the equivalent things that Intel and Nvidia will bring to the marketplace to allow these things to happen. And it has to be the physical, the racks, etc. It has to be the data and the databases. It has to be the data that's in use, that's in flight, the context state of that, the semantic state of that, the agent state, and of course, last but not least, where the humans have approved or not approved of things. So, but the ability of it to look at it as a system as a whole will make this the first time the capability of doing it across the organization as a whole. Taking what really only databases could do before and apply it to the company and the IT as a whole.
Well, frontier models got this all started, and David, we've been very high on the expanding role of frontier models. I mean, we see the core general knowledge capabilities. Maybe those get commoditized, but when you think about what Anthropic, OpenAI, Google, now SpaceX AI, not XAI, SpaceX AI, Meta and others are building. What they're doing is building functional software around these LLMs. That's why everybody's freaked out about SAS. I think we've described the importance of bringing deterministic and non-deterministic worlds together. There's got to be harnesses to do that. It's non-trivial, but the best and the brightest software companies will do that, and of course there'll be emerging ones as well. David, what do you see as the role of the frontier models, and how do they fit into your scenario? Coney, bring up the next slide, and David, walk us through this.
Well, migration is always the challenge when you're going from one environment to the other. How do you migrate? Well, luckily with the frontier models, we have the highest level of intelligence, and the work. There's a lot of poo-pooing of frontier models. They make this mistake or this mistake. Their ability to look at things across the organization as a whole, to look at the code, find problems with the code, look at the code and see how it's working, look at the looking at emails or Slack or whatever it is to find out what's being said about things. Its ability to take all of these sorts of information, which previously are owned by individuals in that organization, and make sense of it, and then offer potential solutions to the leaders, the human leaders that we have there. That capability is second to none. And the frontier model will be a crucial capability that's going to allow this migration to happen. And we've done some significant work here of looking at how this should be done, starting with one part, how you go through it. What are the questions you should be asking? What are the things that you need? How do you then take the output of that and change the software and introduce that new automation level for that particular business process, and then how to migrate that through the organization as a whole. And that capability, that understanding of how you do that is going to be the difference between making the move in a reasonable amount of time and being taken over by some startup.
Okay, Nir Zook a couple of years ago said to me that AI completely changed the security industry. What we used to be able to stop 99% of the attacks, and then the other 1% we could handle with humans. Security has a do-over. So that's something Pat Gelsinger said to me a while ago as well, because that 1% that the humans used to be able to handle can't anymore, because the attackers or the adversaries are so capable and scaling. So let's talk about how security changes and how I'm curious how you see governance fitting into that. Coney, if you would please bring up the next slide, and David, take us through that quickly if you could.
Sure. I mean, yes, the ability of the black hats to do bad things, or people inside the organization to do bad things, obviously grows when you have this type of organization. And the whole area of monitoring changes that are made, on top of that, the whole area of providing capabilities of, for example, monitoring what is it going through and changing and highlighting if there are things that could possibly or could happen. One thing that we think is likely to happen is that you're going to have the one model managing the day-to-day operations of it, and then a separate model which is doing the compliance and regulation and external checking of things as a separate one, if you like, monitoring both the model and the rest of the organization. But this security shifts from the perimeter defense that you had to actually continuous semantic inspection across the system as a whole. It's a totally different way of thinking about how security is and compliance is managed.
So let's talk about the cloud, because the cloud is evolving, and as we've been saying for several years now, into a distributed, system, on-prem, public cloud, edge, space, very clearly a hybrid world. Sovereignty is, of course, the new buzzword and the new mandate for governments and nations, and even, everybody thinks it's just an overseas thing. It's not. Regulated industries also want sovereign control. They're building their own AI stacks. So Coney, bring up the next slide, and David, explain how you see the cloud evolving in the AI era.
Yeah, so we have these units of computing. Clearly, we need multiple of them in different places. We need a federated AI control plane, which allows work to move from one place to another. Maybe the power goes down in one place, allows that migration of work. It has to back up things. There will be distributed systems. Obviously, you'll have some sovereign systems which have to be done in certain places. You'll have other systems which will be maybe closer to the edge or whatever. So this ability to distribute and have sovereign systems will be an extension to the existing capabilities. Obviously, networking being an incredibly important part of that. That would be one of the foundations of that. But it's more than just that. It's the recovery, it's the movement of small pieces of data so that they can be recovered, etc. That again is a capability that will develop in this new platform over time.
So 2 more slides to go, and we got to wrap. None of this would matter if it didn't have a business impact. So let's look at the business impact and the economics of AI. Yeah, Coney, bring up the next slide if you would. I mean, we're envisioning, massive productivity gains. Let's call it 10x. Who knows what the actual number is going to be? Yes, it's going to require some capital outlays, but the returns are going to be potentially massive, measured in you're going to be able to scale without labor. And so here we're showing twice the revenue with the same or even fewer people. David, explain how you see this playing out.
Well, and if you compare new startup systems, startup companies, there's about a 10-to-1 reduction in the number of people per of revenue. That's the starting point. And there are organizations like Simils, EXO, which have shown that that is what you should be aiming at as a level of improvement, not on year one, but over a 3-year, if you're lucky, 5-year time scale. Clearly, the amount of spend on tokens and the whole of this spend, when you're looking at the rate which Nvidia is growing and this whole area is growing, that's you as a company are going to be paying that. We think that's going to grow to about 5x of what it is at the moment. The result of that 10x productivity, well, maybe let's take the 2x revenue. If you are more efficient, if you are providing better services, if you're lowering your costs, you will increase your revenue. You will get a demand increase. So that's the 2x in revenue. And obviously, as a result of this, you'll have fewer people. So that's the model that I'm thinking about here in terms of what is the business imperative behind why the migration to this platform will be, it'll obviously be slow to begin with, but will be very like nothing else we've ever seen before.
We wrote a piece 4, 5, 6 months ago talking about the sort of the crossover point. Imagine a discounted cash flow of you put a bunch of money in, that's the CapEx. When are you going to get the return? And we modeled it out, and of course we were low on the CapEx expectations. $1 trillion plus easily, right? I mean, we're crushing that. I think we had 4 or 5 trillion, so we're on our way. But we said it's going to be an 11-year payback period. So this is going to take some time, and so I want to close on how we see Nvidia and its ecosystem evolving, because this is going to take the better part of a decade to play out. Tony, if we bring up the next slide, essentially the premise here is the time it's going to take can be measured by the functions that the AI factory absorbs. And David, you've laid it out here. So bring us home, and then we got to wrap.
All right. Well, we just go down the left-hand column here. I mean, we have the rack scale GPU systems in place now. They're working incredibly well. And they're going to be coming out next year and the year after that, and a continuous improvement. The AI networking and DPU fabric is working amazingly well. There will be small software and hardware capability improvements that altogether will dramatically improve those as well. But most of that's in place now. Storage is going to move completely towards context storage in support of the systems above it, and in very much lower latency. x86 integration, that is going to be a major functionality improvement that will start to come later this year, and that will be a major improvement in terms of the speed of migration. There's going to be improvement, so be capable. Real-time semantic databases, that's work that's needed to improve the data and the database mechanisms. But databases themselves are going to need to take advantage of this whole parallelism that's available, and then be able to use resources wherever they are. Semantic recovery capabilities, a unified control plane, that's there to some extent, but that's going to be expanding continually later in this decade. And obviously migration will start slowly, but once it gets going, it's going to go pretty fast. And the companies that are still not migrated by the time 2035 comes around, we'll probably not be in a good state at all. I think there's going to be a very rapid migration in the timescale of 29 to 33.
Well, David, thank you for this. Great work putting these slides together and sharing your thoughts. Always a pleasure working with you. Thank you. Appreciate it.
Thank you. It's, I think, one of the most exciting areas, which is going to be a profound improvement in enterprise management.
All right, and thanks, guys. Appreciate the Palo Alto team stepping in while Alex is on the road. Coney and Brendan, thank you guys, and thank you for watching this breaking analysis. This is Dave Vellante. We'll see you next time.